Okay, for number 4, in a figure 4.1, the circles represent the molecules in a different state of matter, A, B and C. So, A, identify the state A, B, C. So, the A, which is a less denser, is a liquid, and B is more like properly arranged, so it's a solid, and C here is a gas. Okay, this is 2 marks over here. Okay, now let us move on with the next one, B. Okay, explain in terms of force between molecules why gases expand more than liquid when they have the same rise in temperature. Assume the pressure remains constant. Okay, first thing is the distance between a gas molecules is further apart. And one more thing here is in gas molecule, the forces between them, okay, the forces between them is much more weaker compared to the liquid. So that's why the gas molecule can actually expand much more further compared to liquid. Okay, now let me write down the answers over here. Okay, these are the points that I have explained to you just now. So first thing is the very large distance between the gas molecules compared to the liquid, and they have a very weak forces between the gas molecules, which makes them to spread apart. Okay, so this is 2 marks over here. Now let us move to the C. Okay, so here figure 4.2 shows a cylinder and a piston. Okay, the volume of gas is 3400 centimeter cube, and the pressure of the gas cylinder is 0.9 multiplied 10 to the power of 5. Okay, over here, this is okay. Now let me explain to you about the Boyle's law. This is Boyle's law. Boyle's law refers the pressure inversely proportional with the volume. Okay, when the pressure increases, the volume will grow smaller. When the pressure getting lesser, the volume will increase. So these are the Boyle's law. So when you are comparing like two situations, you have a P1 V1 equals to P2 V2. Okay, now let us look at the question. Okay, these are the question. The piston is moved to the left and fixed in a new position. Move to the left means it is being here. Okay, is increasing the pressure while the volume is getting smaller. So the pressure of the gas in the cylinder increases to 2.5. Okay, previously 0.9. Okay, assume the temperature of the gas does not change. Calculate the new volume of gas. So we can use this formula, P1 V1, this is for the first situation, and P2 V2, this is for the second situation. Okay, so the pressure for the first one is 0.9 multiplied with 10 to the power of 5. We take this one and this one, 3400. Okay, so we apply it over here, and it become, so let me write it down first, 0.9 times 10 to the power of 5, and then the volume is 3400. Okay, and then equals to the pressure here is about 2.5 times 10 to the power of 5, and then they ask us to calculate the new volume. Okay, so okay, so let me make it much more smaller, or maybe bigger. Okay, now let us do the calculation over here, this part. Multiply 3000. Okay, so here I'll be getting 3.06 times 10 to the power of 8, and then divided with this one, which is a 2.5 multiplied 10 to the power of 5. This is your volume. So the second volume here gives the answer here is based on the calculation. So 1224 centimeter cube. So this is the answer. Okay, this is the answer for this question. 3 marks. Okay, now the next one, number 3. The gas in the cylinder is now heated. The piston remains fixed in the same position as the C1. Okay, any change in the pressure of the gas? Yeah, obviously when, okay, let's say the small explanation over here. Okay, this is the closed structure where you have the molecules bombarding the wall. Okay, when you increase the temperature over here, what happens? The pressure will increase. Pressure will increase. So what is the pressure stated here? The pressure here, it means the rate of the molecule bombarding the wall. Okay, so the explanation can be included as the molecules of gases will move faster, and the rate of collision between the atoms or the molecules and the wall of the container. The wall of container, it will increase. Okay, so this is the explanation of how the pressure will increase. So it's about 3 marks over here, and total marks for this question is 10 marks. Okay, now let us look at the next question. Okay, for number 5, figure 5.1 shows the 2 metal plates A and B with the radiant heat placed midway between them. Okay, here's a shiny plate and here's a dull black plate. So normally the dull black plate will absorb much more heat compared to shiny plate because they will be reflecting most of the heat. So here there's a cork and it's attached with the wax over here. Okay, so let us go through the questions. So the metal plate is shiny, metal B is a dull black. Okay, a piece of chalk is attached to each of the plate using wax. The wax is a solid at room temperature and has a melting point of 37. State and explain what happened to the piece of chalk a few minutes after heater is switched on. So the basic knowledge that we have here, the black plate will absorb heat. Okay, it will absorb heat and they do get hot, but most of the heat energy they will be reflected. So what happens here is the wax at the plate B, it will be melting at a faster rate compared to the plate A. So what happens when the wax get melt? The chalk will fall off. So the chalk at the plate B will fall much more faster compared to plate A. So that is the basic explanation. So I will note down my points all here. Okay, so these are the answer. Okay, now state and explain what happened to the piece of chalk in a few minutes after the heater switched on. Okay, black surface, this is 4 marks. So black surface are better heat absorber compared to shiny surface. This is 1. So that the black surface gets hot faster compared to shiny plate. Okay, 2. Wax at plate B will be melting at the faster rate compared to the wax at the plate This one should be plate A. Okay, so what happened here is the chalk at the plate B will fall off first before the chalk at the chalk on the shiny plate. Okay, so this is my answer suggestion, and sorry for the bad handwriting I have here. Okay, now we go to the B. Okay, state the name of the method of transfer of a thermal energy in a solid metal. In solid metal, we will have a conduction. Remember, heat transfer here, we have 3. So let me scroll down here. It's just a rough explanation. So method of conduction, we have a method of transfer. We have a conduction. We do have a convection. And lastly, we have a radiation. Okay, the radiation is you do not need any medium. It's like between a sun and earth is vacuum, right? Okay, so this is a radiation. So this is the fastest. Okay, this is the fastest the heat can be reached at a certain place. Conduction is the slowest, where it has to go through atom by atom, and conduction is by solid, and the convection is by fluid. Fluid is either it can be liquid or it can be air. It's something like air, example like in our aircon room. Okay, it's a convection. Liquid is like how the water is getting boiled. Okay, so this is a convection. Okay guys, so this is the question number 5. Total marks here is 5 question. It's a short question. So now let us move to the next question here, number 6.